Hi everyone, this is Dr GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, I want to discuss about an important mission element, that is bearings. In this section, we will see classification of bearings, types of journal bearings, design of journal bearing, and then we will see numerical problems on that. First of all, we will discuss about bearings. So what is bearing and why the bearing is required for machinery? So generally, bearings are using for machinery for supporting. So why bearing is required? So what is the mechanism behind the bearing? So I will explain now. The best example, take one shaft. This is a circular shaft. One end will be connected to motor, or another end connected to the rotating machinery. This is a machine. Where do you need to connect this shaft? That is we will call the machinery. So this is a rotating element. The shaft axis is like this. Here we will consider this shaft as a cantilever beam. Why? Because one end is fixed and another end is free. So free means this is a rotating element. They freely rotate in the machinery. While rotating, various types of loads are acting on this shaft. It may be vertical loads, it may be horizontal loads. Due to this vertical loads or horizontal loads, some bending moment will occur in the shaft. Due to the torsion, the torsional shear stress will produce. Due to the bending loads, bending moment will occur. And due to the vertical loads, some center at the center of the shaft, the bending moment will be occur. To avoid this the bending moment and this imbalance of the shaft, we will use support. That support is called as bearing. So another thing is, this is not a static support. This is a dynamic support. Why? Because the shaft is in rotary motion. So while carrying the dynamic loads, the dynamic support is required. If it is a static load, so cantilever, in the case of cantilever beam, and the static cantilever beam, the static load is enough. But for this shaft, this is a rotating element, rotary support is required to avoid the deflections in the shaft. That is called as a bearing. So that's why in our workshops or industries, the bearings are used to avoid this imbalance and to avoid jerks of the shaft. Now we'll discuss about the bearings and how the bearings are classified according to their loads and lubrication property and mechanisms. So we will see in coming of session. This bearing is a machine elements which are used to support a rotating member. So already have discussed in a previous slide. Example, shaft. And at the same time, they transmit the load from a rotating member to a stationary member. So that may be a frame or a housing. So that is called as a bearing housing or a frame. And also the secondary function is they permit relative motion of two members in one or two directions with minimum friction. So that is the specialty of the bearing. Two types of functions are there. One is primary function and another one is secondary function. In the case of primary function, it gives support to the rotating member, and the secondary function, it permits the relative motion between the two surfaces. Mainly, the bearings are classified into two categories on the type of contact they have between the rotating and the stationary member. One is sliding contact bearing and another one is rolling contact bearing. Broadly classified into these two types. So first we will see the sliding contact bearings and rolling contact bearings. In sliding contact bearings, here look at this figure. Here one is a moving element, this is a moving element, and another one is a fixed element. This is a bearing housing, fixed element. This moving element we can say journal or shaft. In this, the moving element slides between the housing and that surface, inside surface of the journal. Whereas in case of rolling contact bearings, in between the fixed element and the moving element, another element is placed. So these are called balls or rollers. If you place balls, this bearing is called as a ball bearing. If you place rollers, rolling contact bearing. Thus, the rotation motion or sliding occurs between these two surfaces with the help of balls or rollers. That's why we will call rolling contact bearings. In the case of sliding contact bearing, no need the external agent. So it means the external agency means the balls or rollers not required. Why? Because the sliding occurs between the fixed element and moving element with the help of lubrication. We will see in the coming of videos. So what are the advantages of sliding contact bearings? So in this, the sliding contact bearings, the design of the bearing and housing is very simple. And they occupy less radial space. And they cost also very less. The design of the shaft is simple. At the same time, some disadvantages also there. So in this, the frictional power loss is more. They require good attention to lubrication. They are normally designed to carry radial loads or axial loads only. So it means in this, it carries radial loads or axial loads only. This is not suitable for the combination of radial and axial loads. And one more thing is, main disadvantage is good attention to the lubrication. Good attention to the lubrication means, while selecting a lubrication oil, we will see the important properties of the lubricant. Why? Because these sliding contact bearings are purely works on lubrication properties. So what are the lubricating properties? Generally viscosity and density, flash point and pour point. These all are important properties of the lubrication. And frictional power loss is more. The frictional loss very high when compared to the rolling contact bearing. Next again, the sliding contact bearings are classified into different types. One is based on type of load carried, and the second one based on type of lubrication, and third one based on lubrication mechanism. So how they classified under these three categories we will see in coming of videos. First we will take based on the type of load carried. In this category, the bearings are classified into three types. One is radial bearings, another one is thrust bearings or axial bearings, and third one radial and thrust bearings, the combined load bearings. So look at this figure. In this radial bearing, the load is acting in this perpendicularly on the shaft. Here load is acting on the shaft, perpendicularly load is acting. So it means in this type of bearing, this is a shaft, the load is acting, this is a bearing element. So radial load will act. So it means the shaft axis is perpendicular to the load axis. These type of loads are called as radial loads, and these bearings are called as radial bearings. See in this figure, so this is capital D, it represents diameter of the bearing, and small d diameter of the journal. What do you mean by journal? So journal nothing but what is how much portion of the shaft inside the bearing, that particular portion is called as journal or shaft. So in this the small d is diameter of the journal, and here H0 is the minimum oil film thickness. So what is H0 we will see in coming of session. And E is it represents eccentricity. So it means while rotating the bearing, sliding contact bearing, there is some eccentricity between the shaft axis and the journal axis. Bearing axis. The radial distance between these two axes is called as eccentricity. It's a very important eccentricity in the case of sliding contact bearings. So always we will keep some eccentricity in the design of sliding contact bearings. Rotation of journal speed N represents. In axial load case, this type of bearings carries only axial load. So it allows only axial load. So in this diagram, you can find the FA is the axial load acting axially. So it means the load axis is parallel to the shaft axis. This is the shaft axis. So parallel to the shaft axis. In this this is the this diagram shows take both radial and thrust loads. So the radial load also it takes this type of bearings are called as combined bearings. In previous case, this is axial load diagram. So in this the load acting parallel to the shaft axis. So here single collar placed. So that's why this type of bearing is called single collar thrust bearing. If you use multi-collar, so multi-collar thrust bearing you can say. Next, this one already we have discussed about this figure. It takes both radial and thrust loads combined load diagram. So next classification based on the type of lubrication. So that is the extent to which the contacting surfaces are separated bearings are classified as. One is thick film lubrication, another one is thin film lubrication, and third one is boundary lubrication. So we will see one by one briefly. In the case of a thick film lubrication, here these two surfaces are separated by the lubrication. So here see, you can find here the gap between these two surfaces are very high. So it means the surfaces are well separated. So there is no metal to metal contact. These type of bearings are called a thick film lubrication bearings. Next one, thin film lubrication. See here you can find there is some metal to metal contact, and here also somewhat contact is there. And here the gap between these two surfaces are very less when compared to the thick film. Here very less gap is there, so it means there is metal to metal contact is possible in this type of bearings. So that's why these bearings are called very thin film lubrication bearings. So here the film nothing but that is the layer, the lubrication oil layer thickness. So that is represented with H naught, as we discussed in earlier, H naught. So this is the minimum oil film thickness. In next one, boundary film lubrication. In boundary case bearings, boundary lubrication type bearings, see here metal to metal contact is there, here also metal to metal contact, and here also metal to metal. So the gap also very less. The gap also very less when compared to the previous film thicknesses, thick film lubrication and thin film lubrication. It's a very small thickness having this type of bearings. So already we have discussed about this thick film lubrication and thin film lubrication. So as shown in figure, the surfaces are separated by thick film of lubricant. So it means there will not be any metal to metal contact. So it means here the film thickness is 8 to 20 micrometer. The coefficient of friction is 0.002 to 0.010. So very less coefficient of friction. So hydrodynamic lubrication bearings are comes under this category only. So in this type of bearings, the wear is very minimum. So we will see that what is the mechanism of hydrodynamic lubrication in coming of session. Next, already have discussed about this thin film lubrication. So already seen in the diagram here. Here surfaces are separated, but a thin film of lubricant is present. So it means some high spots on metal to metal contact does exist. So in this the coefficient of friction commonly ranges from 0.004 to 0.10. So when compared to the thick film lubrication, this value somewhat high. Next, last one, the boundary lubrication. So in this, the surface contact in this the surface count is continuous and extension as shown in figure. So there is a possibility of continuously sticky surface. So and the friction that reduces the friction and wear. So in this coming to the coefficient of friction value, so that is 0.05 to 0.20. So compare these three values, the coefficient of friction, whereas in thick film lubrication this value is very less, and thin film lubrication somewhat high, but whereas in this boundary lubrication, see 0.05 to 0.20. So that's why, so in this the wear rate also high when compared to previous bearings. Next classification, based on the lubrication mechanisms, bearings are classified as three types. One is hydrodynamic lubricated bearings, and second one hydrostatic lubricated bearings, and third one elastohydrodynamic lubricated bearings. See, so don't confuse with the classification. So previously we have classified according to their type of lubricant, the thick film and thin film and boundary lubrication. But in this category, the bearings are classified according to the mechanism of the lubrication. What is the mechanism behind the bearing? So we will see one by one in this. The hydrodynamic lubricated bearings. In this, the load carrying surfaces are separated by a stable thick film of lubricant. So that it means that prevents metal to metal contact. It prevents metal to metal contact, as we discussed in thick film lubrication. And in this, the film pressure generated by the moving surfaces, so that force the lubricant through a wedge-shaped zone. So it means the sufficient pressure built up inside the bearing only. No need any external agency to build up the pressure. So that is the main concept of the hydrodynamic lubrication bearings. So see, look at the figure. So in this, so hydrodynamic lubricated bearing diagram is there. So in this, this one is the journal. So already you know. So this is the, what is the portion inside the bearing we will call as journal. And oil presented here, and this is the bearing surface, and this load is radial load. The sliding contact bearings allows radial or axial loads only. So this is the maximum pressure built up the inside the bearing. This pressure is sufficient to lift the journal and carries the radial loads. So this is journal, and this oil presented filled inside the bearing. And this one is the E. So already we have discussed about this. E is eccentricity. So that is the radial distance between the shaft axis and the radial bearing axis. So this is the journal axis. This is journal axis, and this is the bearing axis. So the second case, hydrostatic lubricated bearings. So in these bearings, the externally pressurized lubricant is fed into the bearings. So what is the necessity of pressurized oil? So in this, to separate the surfaces, two surfaces, so that is bearing surface and fixed surface, and another one is moving surface. In the case of hydrodynamic bearings, no need the external pressurized oil. So why? Because while rotating the journal itself generates the sufficient force or pressure to carry the radial loads. But in this case, the journal is not rotating, and no need to rotate, and no need to build up the pressure inside the bearing. Why? Because here we are using separately the external pressurized oil to fed into the bearings. So that's why here see, do not require the motion of the surface to generate the lubricant film. So that's why these bearings can operate from very low speed to high speed. So as shown in figure, the hydrostatic lubricated bearings. So look at this figure. So in this hydrostatic pressure oil, this is so the pumping here, the high pressure oil supply inside the bearing. So the bearing, the gap filled with high pressure oil. So it means this pressure is used to raise the journal and to carry the radial loads. So externally the pressure is required. In next case, third case, the elastohydrodynamic lubricated bearings. So in this, no need of external agent, and no need of sufficient lubrication also. Due to the contact surfaces of the metals itself generate sufficient pressure inside the bearing. The rolling contact bearings comes under this category. The best example for a elastohydrodynamic lubricated bearing is ball bearings. So it prevents metal to metal contact, and the surfaces finish up to be high for quality. See, the example for hydrodynamic lubricated bearings or ball bearings. So another best example is cam and follower. Another one is gear wheels. These elements comes under this category. See here, the contact between these two surfaces is a rotating element, and this is the fixed element bearing. In between, another element is presented, that is balls or rollers. So due to this contact surface, the sufficient pressure will generate inside the bearing. So why? Because the properties of the, mainly it works on the elasto properties of the metals, the contact surface metals only. So now, up to now, have discussed about the bearings and classification of bearings, and the types of different types of bearings also we have discussed. So next, further the journal bearings are classified into three types. So we'll see what are they. So journal bearings are also called as radial bearings, or it also known as sleeve bearing. Radial bearings or sleeve bearing. So already have discussed about journal. So the portion of the shaft inside the bearing is called as the journal. So this portion requires a better finish and specific property. So I will show you the journal bearing diagram. Here, see, look at this figure. Here journal bearing is presented. So in this, so this is the journal or shaft. It rotates inside the bearing, and this is the clearance between the moving element and fixed element. In this, the fixed element is housing, the bearing housing. It also called as a frame, and this is the oil inlet. So where here the journal while rotating draws oil in this gap clearance. The bearing, this one is the bearing liner, and this is the split type bearing. So in this, see, this is at rest condition, and the metal to metal contact is there. While rotating, when once the journal starts rotating in clockwise direction or anti-clockwise direction, slowly the journal move up, and the gap filled with oil. Slowly the oil filled with this gap. Due to this lubrication property of the oil, the journal will float inside the bearing. So that is the mechanism of the journal bearing. We'll see in next section. See here the types of journal bearing. Again, the journal bearings are classified into three types. So according to their bearing housing fitment. So it means how much the portion of the moving element enclosed with the bearing housing, that is the bearing frame. Here see, first one is full journal bearing, and the second one is partial and fitted journal. So in this case, in the full journal bearing, here the journal inside the journal presented. So here less clearance is there. So in this the moving element enclosed with the bearing that is a fixed element surface with 360 degrees angle. So 360 degrees angle. So it means this journal allows all type of radial loads at any point. It carries radial loads. Whereas in partial, the bearing housing, this is the bearing housing enclosed with the shaft 120 degrees. So actually this is 90 to 180 degrees, but we prepared according to our design standards 120 degrees. In this, so I will tell you one thing. So the journal diameter is less than the bearing housing, bearing diameter, or equal to the bearing diameter. So in this case, in fitted journal, this one also the angle of contact, it actually will call as a angle of contact with the bearing housing is 120. But see here the diameter of the journal. So this is the diameter of the journal is greater than the bearing diameter. So it means very forcefully or tightly fitted inside the bearing. This type of bearing is called fitted bearing, but most probably this full type of journal bearing are used in our machinery. Next, we'll discuss about the basic concept of hydrodynamic lubrication. So in this bearing, hydrodynamic lubrication bearing works on thick film lubrication property. So as we discussed in earlier. And the concept of hydrodynamic lubrication and the mechanism behind the hydrodynamic lubrication we will see in next coming up session. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.